Hello everyone, my name is Han Xiang. This is the question 2 of homework 3 in the probability of and stochastic process course. So in these questions, the x is of the uniform distribution of the range a to b, and the bigger y is equal to the x to the power 2. And we want to find the density function of x and the distribution function x. And for the second question, we want to compute under the condition of a equals to -1 and b equal to 3. We want to compute the density function of y and the distribution function of y and the expected value of y. So in this question, we want to compute first, because of the x is of the uniform distribution, we could compute the density function of x is equal to the probability of x 1 to over the range of the uniform is from a to b, and in this value the x range is from a to b. For otherwise the value is 0. So this part we could draw the big graph, and is from the range a to b, and the density function value is equal to b by b 1 over b minus a. So it's the graph of density function, and for the distribution function is we could compute it as the integral of the density function. The range is from a to x, and for the density function is b minus a, the 1 over b minus a for the integral of t, and we could compute it as the distribution function when the value is 0 when the x is smaller or smaller of a, and when x from a to b is equal to x minus a over b minus a, and when over b x is equal to the distribution function is equal to 1. So we could draw the distribution function graph is when the range is from a to b, when smaller than a is 0, when bigger than b is 1. So, and from b to a to b is a line. So this is the graph of distribution function of x. And for the second questions, the a is equal to -1 and b is equal to 3. We could compute the density function of x is equals to b minus the 1 over 4. X is from -1 to 3, and the other is 0. And for the distribution function, it is equals to the x plus 1 over the 4. X is from a to b, and this is and we could compute the distribution function of y. So the distribution function of y is the probability of the big y is less or equal than y equal to y, and because of y is equal to the x to the power 2, and we could compute the probability of bigger of y is equal to the x to the power 2 less or equal to the little y, and we could transform it to the big X is bigger or equal to the minus root of the y, and less or equal to the root of the y, and it is equal to the distribution function of x to the square root of y and minus the distribution function of minus root of y, and it is equal to, because of the x range is from -1 to 3, and so the y range is from 0 to 9, and but from -1 to 0, the y range is from 0 to 1, so it is different from the other range. So in this part, we could compute it when the y is less than 0, is equal to 0. When the y bigger and equal to 0 to 1 is we could use this part, and it's and the distribution function of x, and is equals to the this one minus this one, and is equals to the root of y over 2, and for from y from the range 1 to 9, this part is 0, so we could just compute this part, and this part is we could use the distribution function of x is equals to the square root of y plus 1 over 4. So, and y over 9 is equals to 1. So this is a distribution function, and we could compute the density function of y is equals to the distribution function of y, the derivative of distribution function of y. So it's equals to the 1 over 4 to times the root of y, and this range is y from 0 to 1, and for this range y from 1 to 9 is equals to 1 over 8 times the square root of y, and for other y's is 0. And we could draw the graph of f density function of y is from the 0 to 9, and for 1 is for other y's is 0, and for 0 to 1 is equals to the 1 to the 1 over 4, and when y is from range 1 to 9, the value is from 1 over 8 to the 1 over 72. So it's the graph of density function, and for the distribution function, when the range is from 0 to 9, and less is 0, over is 1. From 0 to 1, it is this function. So we could draw it at one value of 1 to over 2 is this curve, and for this part is this curve, so it's this curve. So this is the graph of distribution function, and we want to compute the expected value of y. Because of y is equals to x to the power 2, it is two methods to compute it. The first we could compute the expect value of y or the expect value of x to the power 2 is two methods. We could just use the first as an example. The expect value of y is equals to the integral of y times the density function of y. Because of the y range is from 0 to 9, but the density function have two formulas, so we could split it as the range 0 to 1, the y times the 1 over the 4 times the root of y, and the integral of range 1 to 9, the y times the 1 over 8 times the square root of y, and we could compute it. For this part, it's for the y times this is the root of y over 4. So, and to integral of this is the 1 over 6 and times the y to the power of 3 over 2, and from the range 0 to 1, and plus this is 1 over 12 to times the y to the power of 3 over 2, and the basis range of 1 to 9, so it's equals to 1 over 6 plus the 27 minus 1 is equals to the 7 over the 3.